So it gets a bit more greedy and it needs much more to make the same amount of ATP, which is energy. So a cancer cell can be very, very greedy. It's not responding to oxygen in the same way. And they're a bit more selfish. They start sort of multiplying without thought of the broader organism.
Yes.
So the question I have is, how does this happen? Malfunctioning of the what is it that I've done? You know when I ask this question as well? It's because children can get these cancers.
Right.
Or a 90-year-old can get the cancer.
Yeah.
And it doesn't appear to me that a 3-year-old has necessarily made life choices yet that could impact.
But as I said, when you consider forever chemicals that are in the environment, things that we have, that we use in our technologically advanced societies, can get through the placental wall and get these into these children's organs. You have to put it together. Usually it's a constellation of things, because don't forget, I said carcinogens. Some of these carcinogens are fat soluble. Some of these carcinogens can get in and damage those during early stages of development. People always say, how do you explain brain cancer in a 6-month-old baby? Okay, what did he wasn't smoking and drinking and partying all the time, but the mitochondria in a population of cells in his brain became damaged, and that damage then led to this dysregulated cell growth, because the organelle controls when cells should divide and not divide. And then where's the energy coming from? How do you take a highly sophisticated piece of an organelle and making energy so incredibly efficient? And now we're using energy. So this organelle signals to the nucleus, called mitochondrial stress response, retrograde signaling. The nucleus acts as a respondent to what this organelle wants. So the nucleus then, oncogenes, that you've heard a lot about, they open the floodgates to bring in the glucose and glutamine that allow the cell to grow in a dysregulated way. So as you said, they go back to these ancient fermentation pathways where there was no regulation, because this organelle was not part of the problem. So what is part of the situation, the regulation?
So what are the lifestyle factors that are causing this drastically increasing the probability of this happening?
It's not necessarily what the person did in all cases. It's what the person was exposed to. That could have elicited this. That's the oncogenic paradox. So we have shown that inflammation produces these cytokines. When you have an inflammatory heat inflammation, they damage the ability of this organelle to make energy efficiently. Chronic inflammation is known to be a risk factor for cancer. Chronic inflammation. Intermittent hypoxia, carcinogens.
What's intermittent hypoxia?
That's like the sleep apnea, that kind of thing.
Oh, okay.
Warburg had clearly shown that intermittent hypoxia on cells would damage the efficiency of oxidative phosphorylation, leading to a compensatory fermentation. So you have to compensate, because let me tell you, if you don't compensate, you're dead. The cell dies.